Welcome to the Singularity Syndicate podcast, where we bring together leaders, researchers, innovators, and intellectuals to discuss transformative technologies shaping our future. I'm Najah Faisal. Joining me today is Dr. Ibrahim Sabek, Assistant Professor at the University of Southern California, USC, where we discuss AI and its intersection with scalable data processing, knowledge-based construction, and big spatial data management and analysis. Welcome, Dr. Sabek.
Yeah, thanks, Naja, for this opportunity. I'm very happy to be here with you.
I'm sure my introduction didn't even scratch the surface of your credentials. So could you share more about your journey and background and what got you into computer science?
Yeah, so it has been a quite long journey. It started in 2005 when I joined my undergraduate studies in computer science at Alexandria University back in my home country in Egypt. And I've been exposed to many computing fields during my undergraduate studies and been participating into research activities at this period till I graduated in 2010. And after that, I've been involved in many research and teaching jobs till 2012. Basically, I worked as a research associate and assistant in many places like Microsoft Research in Cairo, Egypt Japan University of Science and Technology, Alexandria University as well. I've been touching up in some fields like information retrieval, machine translation, networking systems, computer vision, and also a little bit of databases at this time. But then I decided by 2014, I think, to pursue my PhD, and then I applied for many schools. I've been lucky to be accepted at the University of Minnesota. I've been working extensively since this time on big data management and analysis, specifically on spatial data. And I've been exposed to how we use machine learning and databases at the same time, specifically focusing on the geographic data, data that has location. And after that, I finished my PhD in 2020, and I moved to MIT to get more experience in this field. I've been working there as a postdoc associate for 3 years till August 2023. Been working also on the machine learning and databases in general. And since I joined USC as an assistant professor in August 2023, I've been getting more involved in how we use machine learning for building systems on larger scale, data-intensive systems in particular, and many other aspects that's related to that. That's basically my journey in brief.
That's a very impressive journey. I usually ask my guests, and not all of them are computer scientists like you. And I'm sure that in your experience, you've always kept an eye on the progress of these large language models, even
Right.
before the launch of ChatGPT. But
Yeah.
I still like to ask my guests as a first question about what was your initial first impression when ChatGPT was released and you created an account and then you start, interacting with this system? What was your initial reactions?
Yeah, so that was a life-changing moment at this time when I heard about ChatGPT. I was like any other users. I was kind of interested in seeing what are the things that ChatGPT can do for us. So I created this free trial account and tried to play with some, questions, get some answers. And whenever I post a question, I get somehow a realistic answer that I think that's good. So I keep extensively pressing it to get more complicated questions and answers, and it works great. So at this moment, I thought that okay, this should be moving us to another level, that we can rely on it somehow in helping us in some tasks, like some administrative tasks, like maybe some tedious writing tasks that we are involved in, so we can somehow make use of what ChatGPT can provide us as an initial template, and then we can provide some edits to this. And by that time, you start depending on it on other tasks, like summarizing some articles. Of course, like it's not that perfect, but at least it can give you somehow initial idea on what are the typical points that you should stress on this, like in this article, and so on. So you keep adding tasks to your list that can ChatGPT help you in. So at this point, I think the ChatGPT is kind of something initial that we can rely on now in many things in our life.
Yeah, and the list of use cases keep getting bigger and keep expanding. So it's unbelievable. It is definitely an aha moment from my side as well, because I was reading on artificial intelligence and I always thought, oh, it's going to be far in the future. It's just science fiction for now. And then that was a spark which led me to choose my master's topic or my master's thesis to be on generative AI, as well as it pushed me to start a company to experiment with this technology, as well as starting this podcast. So it's been a catalyst for a lot of things. And I want to know from you about the integration with AI and your fields of research. But before, because we use some complicated terms in the intro, so I want you to unpack what is scalable data processing, what is knowledge-based construction, and what is big spatial data management and analysis.
Yeah, absolutely. So let's start with scalable data processing. So as we know now that we have lots of data generated around us on a daily basis. So this data needs to be kept in somewhere, needs to be processed in a way that can be efficient for other users to use it and also do some analysis on this. So that's what we call it, data processing techniques and systems. So basically you have a database system. This means that you have a system that can take the data from the user, store it somewhere in an efficient representation, and then allow the users the capability to issue some queries against this data, and then process this data in an efficient way so that you can get your answer as fast as you can or in a scalable way. And then if you want to do some analysis after this, like doing some aggregation, getting some statistics, you also have some capabilities that allow you to do that. So that's basically what we do in database systems. And if we add the term scalability to this system, this means that we're dealing with very, very large scale of data. Now it's more than petabytes now of data can be easily added to any application. So now you can imagine we have a scalability issue here. And if you want to deal with all of this data, you cannot do this in a traditional way, like files, whatever you have. You have to rely on systems like database systems. Okay, that's the first term. The second term, the knowledge-based construction. Now you think of this as you have lots of data that's unstructured. So you have images, files, websites, data that doesn't have a specific format or structure, and you want to get use of the information there. As a user, you don't need to pre-process everything in a certain format. You have to rely on something that can keep this data in a structured format that you can use. And that's what we mean by knowledge-based construction systems. So the systems construct the relational format or structured format of your data out of this unstructured data that we have, so that can be ready for you to be used. For example, you want to get some structured tables about the cities and their crime rates. And for each city and its crime rate, you want to get some confidence score about what you extract here. And you just, as a user, can provide us some rules or some heuristics. How can we extract this information? And then you provide this to the system. The system will apply these rules on the data that we have, the unstructured data that I mentioned, like files, images, whatever they're in different formats, and then bring you the answer, which is the structured table. Say that, okay, Los Angeles, this is crime rate, and this is my confidence score. This is San Diego, this is crime rate and confidence score, and so on. So now if you put this in a format like this, it would be easy for you to do some other queries on top of it. Bring me the top city with the highest like crime rate, for example. So now it will be easy for you to do some statistics and analysis after that. And for the third term, the spatial data management and analysis. So it's similar to what we mentioned in data, but focusing now on specific data types, like geographical data or spatial data that has locations. So you can imagine now all of these types of data that can be generated from our social media accounts. When you tweet and you mention your location, I'm doing my check-in now in Paris, or doing my check-in in Chicago. So all of this information is associated with some locations, and you can make use of them in doing some analysis or some query processing. And also data coming from ride-sharing apps like Uber or Lyft or whatever like rides that you have. Even like you can go beyond this, like satellite images for agriculture areas. Also, medical data can be considered as spatial data, because now the brain can be modeled as a spatial object, and it's very important to locate the neurons in the brain and how they correlate with each other. So all of this kind of data have their own like properties as spatial data. So we need to customize some of this data management and processing techniques for them to be very efficient.
Fascinating stuff. And you mentioned social media. I'm in awe on the how the algorithms, these black boxes of social media really works. And maybe I'll use you here with me to really briefly touch on these data processing, because it looks like these algorithms, especially on social media, they track everything, like even the watch time, like how much are you watching on this short clip before you swipe. And all of these are data points are added to construct a profile about you as a content creator and the viewer. And it's fascinating how much data is being accumulated and processed in real time. How do they do all of this stuff?
Oh, that's exactly what we do with the larger scale database systems. So all of these companies that we have now in our days, they have at the back end of their applications, like large scale infrastructure for data management and processing. They are applying databases on maybe on a scale of cloud service, not just machines like what we have typically in our homes. So, and they store this data. They have their own algorithms for pre-processing them, extracting some useful insights out of this. Like, for example, in Twitter, they keep the number of views, the number of clicks, the number of reposts for each item posted there. They keep it ready for other queries that comes after that. So that's basically what we mean by database system. So for each company, they take the database management system and then they customize this for their application needs, but all of them share the same thing. Having infrastructure that can be used for storing, processing, and doing some analysis for larger scale data. That's basically the thing.
So that begs the question: why do they call them black box? Why is it like hard to explain these algorithms, or they are too complex that you cannot really identify why they came up with that conclusion?
No, so the thing here for the black boxes here, I think the term relates to that we can somehow replace one model with another. So in this case, if I have a certain machine learning model that can do some analysis on certain tweets, and if we change it somehow with another model, like the same pipeline of processing the requests using the machine learning model shouldn't be changing, and we just replace one model to another. So it's just a modular modular architecture for their pipeline. So that the whole system architecture shouldn't be changing if we change one model to another. Maybe the accuracy changing because now one model could be better than another, but the architecture and the other facilities or API features or whatever you support for the user shouldn't be changing at this point.
Because I think that there's a big field right now, especially with regard to large language models, but I'm sure that it can be applied to other AI systems, that is related to AI explainability. I had a previous guest on the program who built a company just to do that. So why is it hard to explain the outcome of these AI assistants?
Right. So that's a very good question, because machine learning models, like the modern ones now of these machine learning models, they are depending on more sophisticated approaches like deep learning, reinforcement learning, and other components that somehow we consider that they are doing magic inside their decision making. So it's just, you can consider this machine learning model as a set of neurons, like in a deep learning network. They are doing different possibilities in different ways. They are doing calculations and matrix multiplications in different ways that maybe it's not human intuitive, and they come up with a decision that somehow like matches our expectations. So when we try to understand this, it's somehow very hard for us to do it, because you don't understand exactly. There are no steps inside this neural network, processing or inference call, that can be like debugged or traced in a systematic way. You don't know exactly what's happening, and also based on the training data, so that how this model is working from inside depends on how you train it. So if you change the training data, your pattern of working inside this model can be changing as well. So you don't have like a systematic way to do this, regardless the input that you have or the output that you have. So it's very hard in general. This is a very open research problem, and people started to do some progress in it, but still very far away from being mature.
Do you feel the sense when you look at these algorithms that you're looking at a reflection of our own brain?
That's what Hinton proposed in the beginning. It's similar to how we how our brains work, but there are some differences, like technical differences, but it should be the same way. It should be the same way, like how we activate the neurons and how they interact with each other while they are doing the processing. uh, it's somehow similar to what we have in our brain. There is a big difference in how they work technically, because somehow we still enforce some algorithmic steps where we are doing these activations in the neural networks, that could be not similar to what we have in our minds exactly, but it's similar. Like we try to mimic or like simulate what happens.
That's fascinating. I had yesterday a professor from UCI on the program, and we entered into that kind of discussion or the differences between the human brain and AI. And
Yeah,
he said something really interesting is that the AI required large and large corpus of data, where the human brain evolved to produce intelligence amount of data compared to what AI requires.
exactly.
Um,
Yeah. That's actually a big difference about the technicality of how it works in neural networks on our brain. So whenever we increase the training data that we have for our models, we increase the accuracy and the efficiency of the decisions that we can get from. And if your data that you're training on is very sparse, somehow you're getting misleading answers at the end. So you have to be careful on the size of the training data, on how you train the data, how the data that you're training in is relevant to the problem that you have, because not all the data that you have could be helpful for your problem. You can somehow mislead the training process of your machine learning model if you do that.
What are some of the use cases that are practical in the field as a result of your research? Because you're researching knowledge-based structure, you're researching spatial data and large-scale data. So how is your research being applied in real life?
Okay, so so I've been in all of this work branches that you mentioned. I've been exploring how we use the machine learning or slash AI in different ways. So, for example, in large scale data, we use the machine learning in different ways. So, for example, you have a database system that's already built using some algorithms and data structures that many engineers and developers accumulated experience in building them over years, but now they have some parameters that could be changing according to the input that you have, and then you can use a machine learning model on top of this to improve how we select the parameter values. So the algorithm is there, and then you use a machine learning model to tune the parameters. We call it knob tuning. So that's one level of using machine learning with databases. So people like in industry now and in many companies, they use this in practice. So they use machine learning to direct or guide the way of choosing the parameters that could be useful for the system. That's one thing. Another way of using the machine learning in a practical way is to replace the component itself with a machine learning model. Like, for example, in the database system, we can have a component like a query optimizer or a query scheduler. So basically, these are components that help you schedule the queries that you have from the user and optimize their plans of execution, how we can process them inside the system, and then we return the answers after we do the execution. So these components are built using some heuristics. Okay, so they say that, okay, if you have a query with this characteristics, you should have a plan like this format. That's basically what we had before from our developers experts in building databases. But now with more complicated queries and scenarios, these heuristics prove to be inefficient. So what we can do here is that we replace some of these plans or components using the machine learning model. We have, like, for example, a reinforcement learning algorithm or a deep neural network algorithm that can act as a query scheduler or optimizer. So now you give it some training data, some queries that you had from the past and their answers, and then the model will be trained to act as a query scheduler or a query optimizer. And then when you have a new query coming from a new user, now you output some plans or schedules for these queries. So now you don't know exactly what happens inside the machine learning model, but it will give you a replacement for what we had before as a component built by developers. That's actually started now to be a mature research of direction now. Some companies now, like Google and Microsoft, started to adapt some of these components on different levels. So I've been exploring this branch of work during my period at MIT. I've been built some of these database components using machine learning models, just replacing it, not doing the knob tuning that I mentioned before. Another direction that could be also helpful is to use the machine learning models to somehow replace some of the components we use for the inference and the learning that we have in knowledge bases. So basically, as I mentioned in my knowledge base example, that you have this cities and their crime rates, and then you provide some rules. Basically, when we do this translation for these rules and processing them inside the knowledge bases, we rely on some heuristics. Now we can replace this heuristics with some machine learning techniques that can predict what we need to do in processing these rules in order to have efficient extraction for the information for the knowledge bases. So that's another case. So many cases like this. Now we're trying to go beyond this and even use a machine learning to replace a whole database system. Like, there are some trials now to build all the components that we have in the database system using one big machine learning model that can act as a database system. This is very, very early stage research, but why not? Now the machine learning is starting to be mature and practical compared to previous times. So we're now exploring this somehow.
That is fascinating. So machine learning algorithm becomes the data structure.
Right, yeah. So yeah, basically we can use this machine learning to build an index. We can use the machine learning to build the hash table. We can use the machine learning to build a query optimizer. So now you remove that data structure and you place this with a mapping function using your machine learning model. And this is actually one of the very famous papers in 2018 by my previous postdoc advisor at MIT, Tim Kraska. He was proposing this learned index. He replaced the index structure that we have with a model that's trained. So now, instead of asking the data structure, give me the key with this value, now you ask the machine learning model to predict where this key is located. So you just use the prediction from the machine learning model to get you the answer. So now you don't have any tree structure or any data structure that we use typically. We replace this with a machine learning model.
Is that more efficient or?
Yeah, of course. So it has its own advantages and disadvantages. So that it's more efficient in terms of the size. You can think of it like the machine learning model. If you want to store it, you need to store its parameters only. So think of it like if you have a linear model, and this linear model is represented by a, the slope, and b is the bias. So when you're like storing this model, you just need to store these two values, a and b. But if you have a tree structure, you have nodes, you have edges. If you want to store it, you have to keep the whole structure like in memory or whatever there. So of course, in terms of storage, you can have orders of magnitude reduction in the storage overhead. In terms of the accuracy, yeah, if you rely only on the machine learning models, you can face some cases that your prediction could be wrong because this is probability at the end. But with adding very efficient optimization tricks that can correct this mispredictions in these cases, then you guarantee that you have both efficiency and storage efficiency as well, like the efficiency for the processing and efficiency in the storing as well.
Another important question that I've always wanted to ask scientists like you regards the ethics of AI. And right now we depend on AI on everything. Like when you apply for a job, an AI system is scanning your profile to see if it will bring you to a human to look at it or not. When you scroll social media, everything you see is curated by an AI algorithm, and the more you like and engage with a specific type of content, the more it gives you more of that specific mindset or ideology. And now we have these large language models, and we depend on them. And I'm sure that you agree that in the very near future we will be only interacting with these models when we talk to machines. They will be the interface of everything.
Right.
So I'm wondering if you are worried about like the biases and the morality of it all, and what can be done to really protect ourselves and design systems that are more fair and just.
Yeah, that's a very good question, and this is the question that we have been asking now ourselves for like in many fields as researchers. Like since this invasion of the machine learning and AI in these different computing fields, we have like privacy issues, we have fairness and biases issues, we have explainability issues. All of them somehow they merge to the same thing. Like we have to protect ourselves against the bias that can be happening. So how can we do that? And one obvious thing that we usually try to improve here is controlling the data that you're trying to use for training your model. So this data, if it has very obvious biases, then the model itself will be biased at that. And we have a lot of work now in the databases now. They try to focus on the data pre-processing step. Now, when you store the data in your database system, before doing this, you start doing some checks, some analysis. If you have some missing values, if you have some hacked values that are somehow changed by some hackers or whatever their malicious activity, how can we correct them before storing them in the database system and using them for training the model? So this is like, an important aspect that we are looking for now. And now we are also having another direction. Now, after you generate the prediction or the decision from the machine learning model, how can we evaluate its robustness? How we can give it a score somehow that it's not biased, so that when we get this answer, we before return it to a user, we do some checks and get some confidence interval for whether this result will be trusted or not. And then if it's not trusted, we prevent it from the user and say that, okay, you have to try it with another training data, or we have to run the model again, or we have to check what's wrong in the model, because this could be an issue. So you can work on two directions and even combine them, like doing the data pre-processing and also the decision post-processing.
My last question to you
Sure.
is, I want you to speak to the 16 years old version of yourself. Picture Ibrahim, who is 16 years old, trying to figure out what he want to do in life.
Right.
What advice would you give them? And the reason why I'm asking this question is because when we were young, they were like, okay, study, learn how to code, because the
Right.
coding is the future. Now AI can do coding perfectly well.
Right.
Don't learn humanities and psychology and philosophy and all of this stuff because they're not in trend or whatever. So what would you give the young Ibrahim advice in terms of where to go and what to do with their lives in the age of AI?
Okay, so this question, the answer for this question depends on whether you wanna have some good practices for developing yourself in the AI field or in general. So let me try to answer them in both ways. So if you want to focus on how you develop yourself for the AI age that we have here, I would say that you don't have an excuse now. We have a lot of resources online. Even big universities like MIT, Stanford, they are putting their courses online for free. You can go there, you can check the trending topics, the very recent up-to-date materials, and they post this on a yearly basis. So it's ready for you to use. All you have to do is to put some effort in checking what's there. And also we have a lot of open source projects now and tools. Now we're like having this culture trend of open sourcing our source code and materials, especially in the research community. Now we have a lot of projects implemented on GitHub or whatever, like code repository there, and then you can just download them, follow the documentation there, rerun the test cases. You familiarize yourself with the techniques or the details there, how to use the machine learning, how to use the AI inside these projects. Now this can give you a good inspiration for how to use this in another problem that you are interested in. And I personally did this. Whenever I go inside a certain topic and I want to familiarize myself, I go through some of them academic materials online, and then after that I do some practices with a couple of open source projects that I can download and redo the steps there and investigate the source code and whatever materials that they have. And in general, if you want to prepare yourself for a computer science job, not just in AI, I would say still you have to master the coding, um, like the coding practices. Yeah, you know that there are some of the jobs now, or maybe IT jobs that could be replaced by some of this AI generated codes. But still, the low level system building or the engineers, back end engineers, they are very far away to be replaced by the generated source code or whatever generated codes by the AI tools that we have now, because they require some innovation in the design from an engineering perspective. And I tried this in a couple of items or projects to replace some of my low-level system code with generated source code from something like ChatGPT or whatever there, and it proved inefficiency. Now, maybe in the future they train the models to be, or customize the training for the models to be efficient in this part. But I would say it's still very very early to rely on something like this. So you have to practice coding still. You have to be up to date on whatever we have in the AI or the machine learning fields in general, so that you know what you can do and what the machine learning can do. So all of this stuff can be good practices for young children or young engineers to be to be up to date with the field. And for myself, I would like, or I would love to start doing these tricks for my son at a very early age, like at 8 years old or 9 years old. Now we have some tools also to practice this stuff on a very early age, like doing some programming, coding blocks and stuff. So whatever you can do at this early stage can help you in the future to build some skills.
So you're still betting on the STEM subjects. The computer science field is still promising, in your opinion. It's not gonna. You wouldn't recommend to your son to go and study philosophy and study
Yeah,
consciousness and
I
intelligence
think
and.
it's still useful. Yeah, I think it's still useful to master this stuff, because if you don't have the proper background for them, uh, now you're completely blind to what are the problems that can happen from the AI generated source code, because you don't know how they generate the source code. At least you have to understand what they are generating, and now you can correct them, and maybe modify them if it can do the job instead of you. But if you're completely ignorant of this stuff, you're lagging behind. So you have to still master these skills.
Dr. Ibrahim Sabek, this has been amazing. Thank you so much for taking time to speak to me today.
It's a pleasure on my side to be with you.